Hi Bobcats! In this video we're going to take a look at the concept of molar mass, or the mass in grams of 1 mole of a substance. Our objectives are to first define what molar mass means, and then to calculate the molar mass of a compound from its formula. And once again, I'm going to work in a little bit of nomenclature review. The molar mass is simply the mass of 1 mole of a substance. It's reported in grams. For all of the elements that are present in a compound, we're going to multiply the subscript that's on that element in the chemical formula times the mass that we get for the element off of the periodic table. The mass that we're looking for is that average atomic mass, so it's the number that has the decimal places after it in the periodic table. Once we've done that for one element that's in the substance, we'll repeat that for all of the other elements and add up those numbers to get the total molar mass. As an example, let's take a look at finding the molar mass of sulfur hexafluoride. Before we can find the molar mass, we need to know the formula for the compound, so we know what elements are involved and how many atoms of each. Sulfur is a nonmetal, fluorine is a nonmetal, so it's a nonmetal plus a nonmetal. That means it's covalent or molecular, and the prefixes tell us what the subscripts are. There is no prefix on sulfur, so sulfur will just be an S. And then we have hexafluoride, so hexa means 6, and we'll stick a subscript of 6 on fluorine. Now, when I go to the periodic table and I find sulfur, the average atomic mass is 32.066. That's really close to 32, so I'm just going to round it off. And also notice that since there is no subscript written on the sulfur, it's understood to be a 1. So let's multiply by 1 for the subscript, and then 32 for the mass in the periodic table. And that takes care of sulfur. Let's look at fluorine now. We have 6 of them, so we'll multiply by 6 to start. And then for fluorine, the molar mass is 18.998, so I'm just going to round that to 19. Now, if I run this through my calculator, again, I'm not a big fan at all of doing parentheses. So what I like to do is no parentheses. Multiplying by 1 doesn't change anything, so I'm not going to multiply by 1. So I'm just going to type in 32 and then plus 6 times 19. And that gives me a molar mass of 146. When we put units on this, there are 2 units that are acceptable. One is just plain grams, or the other thing you can say is grams per mole. So either grams or grams per mole are acceptable units. It seems like each chemistry teacher has different ideas about how they want you to round molar masses. So for 1310, I'm going with the keep it simple principle. What I'd like to do is when you read a molar mass off the periodic table, round it to 1 decimal place, and then I'm going to go even a step farther and say if that first decimal place is a 0, then just don't even write it. So for instance, down here with the element carbon, if you look at the periodic table, it says 12.011. If we round that to 1 decimal place, we get 12.0. So let's just go all the way to just plain old 12 for it. Chlorine, on the other hand, behaves a little differently. Chlorine, if you look at the periodic table, says something like 35.45. If we round this to 1 decimal place, we get 35.5. So let's just leave it there at 35.5. And then again, for the units, we can either write grams per mole, because the molar mass is the number of grams that 1 mole of the substance weighs, or because we're calling it molar mass, which implies it's for 1 mole already, we can just use units of grams. Either one is just fine. So let's find the molar mass of calcium chloride. Calcium is a metal, and chloride is a nonmetal. So when we have a metal plus a nonmetal, it's ionic, and we have to get charges to cancel out. So calcium is an alkaline earth over there in group 2, so it's +2. Chlorine is a halogen, so when it forms that chloride ion, it'll be a -1. Since +2 and -1 don't cancel out, we have to crisscross, so we'll bring a 2 down here and a 1 down here. And when we clean that up, we don't write charges, we don't write the arrows, and we don't write the subscript of 1. So this just becomes CaCl2. When I look at the periodic table for calcium, there is 1 calcium, and it has a mass on the periodic table of 40.078. So if I were to round that to 1 decimal place, that would be 40.1. And then for chlorine, there are 2 of them. And chlorine, according to the table I'm looking at right now, it's 35.453. So rounding that to 1 decimal place would be a 0.5. Now I can just run that through my calculator. I'm going to have 40.1 plus 2 times 35.5, and that gives me a mass of 111.1 grams, or grams per mole. Either unit is fine. Now I'm being careful here to write out subscript times average atomic mass, subscript times average atomic mass. Really, when I do this, and I'm not trying to be so very careful, what I would write here, I would just write 40.1 for the calcium part. I don't show multiplying by 1. And then I would do like 2 times 35.5. So probably that's the way you'll see me calculate a molar mass as we work more problems in the future. Here's an opportunity to see if you can calculate molar mass. Grab your periodic table, add it up, see which one of these answers you get. Pause the video, and we'll continue in a moment with the correct answer. All right, so what is the molar mass of methane? So this ANE ending tells us that we have an alkane. Alkanes have the formula CnH2n plus 2. This prefix meth means that N equals 1. It means 1 carbon. So we have C1, and then H, we're going to take 2 times that. So 2 times 1 is 2, plus another 2, which gives us 4. So our formula for methane is CH4. When you look at the periodic table, carbon is 12.011, so that'll round to 12.0, which I'll just write as 12. And then we'll add 4 hydrogens to it, and hydrogen is 1.008. If we round that to the first decimal, it's 1.0, so I'll just round that to 1. So this is 12 plus 4, which is 16 grams, or grams per mole. So that is answer C. Did you get it right? Good. Excellent. To wrap up this video, our objectives were to define the molar mass and to calculate the molar mass of a compound from its formula.